All right, we got lesson 7.5. It is the last lesson in chapter 7. We're going to shift gears a little bit here. We're going to talk about trapezoids and kites. We've been talking a lot about parallelograms, but hey, not everything's parallel. So we got some trapezoids and kites. First, I want you to go ahead and do these three first. So we have the mid segment of a triangle. Hopefully you didn't forget what that is. So pause this video and solve for all of those missing values. All right, oops, was number 3 y taking you a little bit? I forgot to tell you. That one, you need Pythagorean theorem. Could you do it? Absolutely, yes you could, but we're going to go ahead and skip that. So number 1, the value of x is 4, because it would be the same length as MC, because it is the midpoint. And y is 5.5, because we take 11 divided by 2. Now, in number 2, x would be 24, because we double 12. Remember, mid-segment is half the length, so the full length would be 24. And y is 10, since Cn is 10. Now, number 3, the value of x is 9, because again, m is the midpoint there. And I wrote in 17 because we could use the Pythagorean theorem and figure out why, but we're going to actually return to the Pythagorean theorem in chapter 9. So we're going to go ahead and skip y on that one for now. All right, pause again, figure out these 6 missing angle measures. All right, on number 5, I'm actually going out of order because first I want to do angle 2, alternate interior, that one would be 60. Then I know that this is a linear pair or a straight line, so 180 minus 60 gives me 120. Now angle 3 here is also a 90-degree angle because it's a parallelogram, consecutive interior angles. Those would be add up to 180, so since one's 90, the other's 90. Number 7, we're looking over here at angle 4. Well, it would be congruent to this angle because they're alternate interior, so that would also be 45 degrees. Then angle 5, we got a linear pair again, so 180 minus 45 is where I'm getting that 135. Now, number 9, you could do this a couple different ways. You could figure out the value of the whole entire thing because it's quadrilateral and subtract it from 360. Or, in my opinion, the easier route, since these two lines are parallel, consecutive angles have to add up to 180 degrees. Well, 180 minus 71 is where I'm getting that 109 from. We are going to just take a really quick look at this problem. Is this a trapezoid? If so, is it isosceles? Well, I just want to make sure that you know an isosceles trapezoid, just in case you forgot, is if 2 of the sides are congruent. So to show that it's a trapezoid, we have to have one pair of parallel sides. That's the definition of a trapezoid, one pair of parallel sides. Well, the slope of RS is up 1 to the right 2, so that's 1/2. The slope of OT is 2/4, which also reduces to 1/2. Because those slopes are the same, they're parallel. So yes, it is a trapezoid. Now, is it isosceles? Well, RO, that's an easy one, right? Just 3 units long. But what about ST? What is the length of ST? How are we going to figure that out? Did you guess it? Distance formula. So if we take a look at it, the length of ST would be the square root of 8. Well, the square root of 8 is definitely not 3. I'm not even going to get my calculator out. It's 2 point something. So this is shorter. So no, it is not isosceles. It's just a plain old trapezoid. All right, go ahead and graph the next 4 points, and we're going to decide too, is it a trapezoid or is it more special? Is it an isosceles trapezoid? All right, so taking a look at AB, that has a slope of 3/9, which reduces to 1/3, and CD has a slope of 2/6, which also reduces to 1/3. Same slope. Those lines are parallel. Now, not the best drawing, I know, but BC over here, we can just count the squares. Nice and handy that it's right on the lines. It has a length of 5. If we do the distance formula, we'd end up with 3 squared plus 6 squared, square root of that, which is the square root of 25. Well, the square root of 25 is 5. So yes, it is an isosceles trapezoid. Here we've got 3 more theorems. So for an isosceles trapezoid, this is very similar to an isosceles triangle. In an isosceles triangle, sketch one over here. Whoa, that does not look like it, but pretend it is. The base angles were congruent. Same thing for an isosceles trapezoid. Those base angles, as you can see, A and D are congruent. and B and C are congruent because it's like we took the triangle and we cut the top off. So both sets of those angles are congruent. The next theorem, the isosceles base angles converse, says, hey, guess what? If you already know that the angles are congruent, those base angles, then it forces that shape to be a trapezoid. So the first one is going one direction. If we say it's an isosceles trapezoid, then we know the base angles are congruent. The second one is going the opposite direction, saying if the angles are congruent, guess what? It's an isosceles trapezoid. Now this last one is unique, kind of like a rectangle. If it is isosceles, only isosceles, not any old trapezoid, then those diagonals are congruent to one another. So all three of these theorems are just about isosceles trapezoids. Let's take a look at these three examples. So if you want to pause the video, this would be a good time, and then you can try to work through these on your own. All right, the measure of angle K would be 85 degrees as well, because we know that this is an isosceles trapezoid. Those sides were marked congruent, so that forces those two angles to be the same. Now, a couple different ways we can do this. One, since these two lines are parallel, these have to add up to 180, so 180 minus 85 would force angle M to be 95 degrees. Well, if angle M is 95, angle J is 95. That's one way to think about it. If you'd rather go the quadrilateral route and say total is 360 degrees, well, I've used 85 and 85. That would be 170. So I'm left with 190 degrees. Divide that by 2, 95 and 95. Either way, you want to think about it. All right, number 4. Is this an isosceles trapezoid? Now, we know that these two sides are parallel. But what do we know about the diagonals? So great, it's a trapezoid, but is it isosceles? That's what I care about. Now, it's not marked in the diagram, but it does tell us that EG is congruent to FH. So EG is congruent to FH. Well, if those are congruent, those diagonals are congruent, therefore, yes, it is an isosceles trapezoid by the isosceles trapezoid diagonals theorem. That third one we just took a look at. All right, number 5. Using that same diagram, let me erase here. If HEF is 70 degrees and FGH is 110, is this an isosceles trapezoid? Well, let's take a look. If this is 70 degrees, we can figure out what this angle is. They have to add up to 180, so that makes it 110. I don't even need to go any further because I have one set of base angles are congruent, so that's going to force the other one. Now, if you want to think about it, we could figure out what this angle would be because these two have to add up to 180. So that's 70, and now we can see that both sets of angles are congruent. All right, we're going to pause here for the first part of lesson 7.5. And we'll pick up with a little bit more about trapezoids and kites.